Well, thanks everyone for coming. Huge thanks to Geekdom for hosting us. Really appreciate it. And they're probably all already gone, but there were as many t-shirts as I could cram in my suitcase from England out front, so help yourself if there are any left. And yeah, I hope everyone got a bit of food and drink. So yeah, I'm Luke Marsden. I'm the CTO at ClusterHQ. I'll just very briefly mention what ClusterHQ does. We are a company that is building an open source product called Flocker. And Flocker makes it easy to run databases in Docker, basically. Makes it possible to run stateful containers and then move those containers around between different machines. And it turns out that moving things around is a useful primitive to have if you want to be able to manage your applications once you've deployed them. So that's enough about ClusterHQ. Tonight I'm going to talk about containers and microservices and sort of a little bit on what I see as sort of the road ahead, specifically the road ahead in the container ecosystem to better support microservices in general. But first, just quickly, I guess, so who here knows what microservices are? Yep. Who here actually builds microservices? Cool, quite a lot of people. And I guess everyone knows what containers are? Yes. Cool, so yeah, microservices are obviously like complex applications that are composed of many little pieces, independent pieces that can be deployed independently, that communicate with each other via language agnostic APIs. And that's a pretty revolutionary way of being able to speed up like time to delivery of updates to those things and separate them. And our special guest, Adrian Cockcroft, is going to talk much more about that later. And as everyone knows, containers are a way of encapsulating a program and its dependency in a way that it can be deployed in a consistent way across multiple machines. And they work really well together because before containers, the only real way of isolating applications was using virtual machines. And virtual machines are quite heavyweight. And so if you have to separate your application dependencies up with VMs, then you can't really make your services that small. So being able to have like a high density of containers per machine means that you can host microservices, many of them on the same box or on the same VM, and then you can scale them independently by moving them around. And so I'm of the opinion that containers, as a result, are a fundamentally better abstraction for packaging up applications into a deployable, upgradable piece. In fact, I think that doing that with virtual machines is pretty wasteful. The other big benefit, as everyone knows, of containers is portability. So they sort of solve the deployment matrix of hell. And I'm sure most people have seen the Docker deployment matrix of hell, which is like all the possible cloud providers and so on, like just all the possible ways that you could deploy applications across different cloud providers and in conjunction with other applications makes for a really difficult time when you actually want to deploy things. And that's great, but there is something of a sort of vacuum of tools around containers. I mean, if you look at containers as, like if you accept the premise that containers are the new type of virtualization, then if you look at all of the tools that were built around virtual machines and all the tools and all of the sort of infrastructure that built up around VMware and then AWS, and then if you put Docker in that same, or put containers in that same sort of central position, then there really is a sort of a vacuum of, or at least until recently, there was a vacuum of tools around managing containers in production. And so that's one of the reasons that you've seen, along with the great growth in popularity of containers, that's one of the reasons that you've seen a lot of new tools pop up around making Docker more manageable and so on. Now, it's unfortunately a fact that real applications run on more than one computer, more than one server. and or at least they ought to, for reasons of scalability and reasons of reliability, because computers are fundamentally unreliable and they can only get so big. So you really want to be able to distribute an application across multiple machines. The downside with sort of the set of tools that was available to people wanting to actually deploy containers, deploy their microservices in containers until fairly recently was that, like if you take Fig for an example, has everyone heard of Fig? Yeah? So if you take Fig, which is a way of composing a set of containers into sort of one unit, and then be able to deploy that, it would only enable you to deploy that sort of collection of containers onto a single host one at a time. So Fig has these. I think Fig is really an awesome project, and it got a lot right. The sort of developer experience that gives you is great. You can define links, ports, and volumes, and environment variables for your containers. And that's pretty easy to implement when all those things are running on the same host. Like links can just be IP tables redirects, and ports are just more IP tables, and volumes are just like some local path on the file system. And environment variables are obvious. But like as soon as you go to a multi-host environment and you want to be able to deploy your microservice that's made up of multiple components across multiple machines, then you run into these classic problems of storage problems and networking problems, basically. And so I'll break down some of those problems and talk about them in turn. So yeah, I mean, to be able to run our workloads anywhere, we need to be able to run them on more than one computer. And in order to do that, we need portable, container-aware solutions to the following things. So composition is one I already mentioned. So while microservices are small, they're typically made up of more than one process. You actually want a collection of containers that run sort of maybe as a unit, maybe not all on the same machine, but they run together. And that's what makes up a service. So that could be like an API front end, maybe a scale-out API, and a database, or something like that. Or like some caching service, or a queue, for example. And there's lots of activity around composition. So like Fig, I mentioned already. Kubernetes have their kubelets, or their pods, and their replication controllers, and this sort of three-tier architecture. And in general, there's sort of lots of YAML and JSON flying around. Like AWS have come up with their own thing for their container service. And these are great primitives, but like I say, when we go multi-host, we've got some problems to solve. Scheduling, I guess, is sort of the next category, which is basically just choosing which host to run a container on. And then in an ideal world, a system that does scheduling could also automatically reschedule containers to keep hosts balanced. So like if one machine is running really hot and another machine is kind of quiet, it would be great if like the scheduling framework could say like, oh, move some of these containers over here, or stop some there and start some on the other machine. And for example, Mesosphere is a really good example of something that does this at scale that's production ready. And another thing that's important for the scheduler to do is to recover from a failure when a host fails by rescheduling those services somewhere else. Networking, I guess I kind of break down into two pieces. The first one is like how do containers find each other, which is a service discovery problem. And there's lots of solutions out there, like Console, that allows you to do that, and lots of people can sort of build their own as well. And the second sort of piece of the problem, although related, is like how do these things actually talk to each other? And there's projects like Weave and Socket Plane that have shown up that give you sort of a container network where you can attach a set of containers to a shared sort of flat L2 network space, and then they can communicate with each other over that. And maybe the containers can have like static IPs. So even if the container's running on a different machine, then the static IP can always be the same, or like maybe they have DNS names or something like that. And there's kind of two approaches actually to this. The first one is, so in a Fig file, you can define links between containers. I quite like the idea of being able to extend that to multi-host links. And actually, that's something our project Flocker already does. Or you can have this sort of Weave style idea of like each container has its own explicit sort of identity on the network in terms of an IP address or a DNS name. And then sort of onto storage. So stateless containers are all very well, but at the heart of every sort of real application is some data or a database. And it's all very well to say, well, let's just use the services that are provided by the cloud providers. So AWS has RDS, for example, and that's a great way to get managed MySQL or Postgres. But the whole point of this whole exercise is that we want to be able to provide sort of truly portable application environments, right? We want to be able to develop this fig file or whatever on our laptop and then deploy that in a consistent way, whether it's like on a bare metal machine or set of machines or onto AWS or like Azure or Rackspace or whatever, or Google Compute. And it would be great if the data services weren't dependent on the cloud provider. So there's an opportunity to sort of remove lock-in here. And so I think if we can find a way to implement support for stateful services as well as stateless services, then that will improve the overall portability of these application bundles that we're defining. And so, so this sort of brief tour of the container ecosystem, I hope, was useful. It sort of feels like we've got some of the pieces coming together for, let's say, a container native solutions to some of the big sort of problems of computing and distributed systems. I guess you could characterize it as like the container ecosystem is trying to deliver on a portable AWS, perhaps. I'm not sure how well that metaphor works, but the idea is that if you can run something like on one machine, if you can run it on a set of bare metal machines, and you can run it on a cloud provider that's just giving you storage and compute and networking, then we really can build apps that can run anywhere. And that's the promise of Docker. So we just need to solve these big fundamental problems first. So I like this tweet from Adrian Collier, another great British Adrian. And he says that now the Docker ecosystem needs to work to enable all these solutions to get used together. So it would be nice to be able to say, like, oh, I want to use Kubernetes style of defining apps. Like I really, for some reason, I like the pod plus replication controller architecture for defining things. But I actually want to use Flocker for my volumes, perhaps, because I like the way that it enables me to move like my database from a small VM onto a bigger VM when it needs to scale. And I want to use a Weave network for this so that it's easy to sort of figure out how the containers find each other and communicate with each other. But the reason that this doesn't work right now is really due to one of the problems for sort of vendors or folks trying to build stuff in this ecosystem around Docker is that Docker hasn't had a true extensions mechanism. And so if you wanted to build like a platform, or if you wanted to build like a storage plugin or a networking plugin, there was nowhere to plug it in apart from the Docker Remote API. But the problem with the Docker Remote API is as soon as you wrap the Docker Remote API, then you have to provide the entire user experience for the person who wants to use that tool. So, for example, like Flocker, the project we worked on, has a Flocker deploy command. Instead of using the Docker client, you have to use the Flocker client. And the same is true of Weave. If you want to use a Weave network, then because they have to do some funky stuff to set up the network before a container starts, then you need to use this. You need to type Weave run. And the user can't both type Flocker run and Weave run. So there's some collision over the interface. And what's more, it's not possible to use that all with Kubernetes, because Kubernetes or Swarm from Docker or whatever orchestration framework you like for whatever reason also wants to talk the Docker Remote API. And so we've ended up with this sort of picture like this. We've got like some sort of orchestration scheduling thing, which I've just put in a box to keep it nice and abstract, like however that works. That might be a Kubernetes or a swarm or a mesosphere. And that is sort of a one-to-many. So it's taking like input from the user via whatever API makes sense for the orchestration and scheduling framework. And then it's turning a bunch of machines, like Docker hosts, into the places where the containers actually get run. And that's sort of the picture. And then so people like us came along and we were like, well, we want to do some cool stuff with storage. Like we've got this great way of doing portable volumes. It would be really nice to be able to just plug that in. And the same with the networking guys. But there's nowhere to plug it in because all the interfaces are already plugged. So what I'm proposing for this is, and what actually, not only I am proposing this, but the entire ecosystem has worked together to start getting to the point where we have real Docker extensions, is to have a plugin mechanism sort of here. And so these are hopefully what Docker extensions are going to look like. A way of plugging in sort of on a per host basis, maybe say Docker plugin load weave or Docker plugin load flocker, and then have that register in some way with the Docker daemon in order to provide these hooks. And I think if we can do that, then we can end up with a pretty healthy outcome for the ecosystem, which would allow us to which would allow cluster admins to use their choice of orchestration, their choice of scheduling, and their choice of networking and storage providers. And something I want to point out, so if we dig into like what these things actually look like, the sort of extension points, there's a few things that I think are really important. These extension points need to be late bound, they need to be composable, and they need to be optional. So late bound means that extensions have to be loaded, they have to be loadable after Docker is compiled. We want to be able to not have to compile a plugin into Docker in order to get it deployed somewhere, because that's quite a pain. And also means they wouldn't be composable unless they were all accepted into Docker core, and getting stuff accepted into Docker is kind of tricky. And Go has no dynamically loadable libraries, so this means extensions must be out of process. Composable means that you must be able to use more than one plugin at the same time. So, for example, a Flocker plugin and a Weave plugin should be loadable at the same time. And they must be optional, which means that when Docker starts shipping like Swarm for orchestration, or they start shipping their own networking implementation, then it's necessary that those must be removable and someone else's plugin installed instead, if that's what the cluster admin wants. And they promised to do this, which is great, using the phrase, so batteries included but removable. And so I'm all for this. I think it's going to be great for the ecosystem. I think that we'll encourage lots of innovation around Docker extensions. And I think that will be better for people doing microservices, because they'll be able to sort of realize this vision of having a system which manages containers across multiple hosts, that has storage abstractions and network abstractions, and that the ops people can actually manage, so that the devs can get on with what really was the promise of PaaS all along, which is just deploying code and have it work. So we're going to be launching something that helps with this soon, so check out our blog and watch this space. And so thank you all very much for listening. And yeah, thanks. Any questions?
So I can see that on the back end. From a front end, so do you see any value to tightly coupling it to Docker, or making it, having some sort of a plugin mechanism, so alternatives like Rocket could just as easily use the same framework?
So the question was whether it makes sense to tightly couple it to Docker, or whether it makes sense to make it, I guess, even more pluggable, such that you could have different container runtimes. Sure. I mean, in principle, that makes sense. But I think if we're going to have a Docker extension mechanism, then it needs to be Docker, really. I'm not saying that there shouldn't also be extension mechanisms for Rocket. And I guess like you can look at it from the other direction as well. So from the orchestration framework's point of view, it might make sense to have different plugins for different container runtimes. But really, that's the job of the orchestration framework, to talk a different remote API to a different container runtime. And Rocket doesn't even have a container. It doesn't have a remote API because that's not in scope for that project. So yeah.
This is a question about Flocker specifically. So it allows you to move the data volumes for the stateful containers around. Can you share the multiple stateful? Can you share a stateful container with multiple stateless containers with multiple Docker instances?
So the question was, with Flocker, can you share multiple?
Can multiple container instances read a single persistent data volume?
Can multiple container instances read a single data volume? You mean across multiple hosts?
Yes.
So at the moment, no. And I kind of feel like sharing a POSIX file system is the wrong API for cross-machine communication. Because as soon as you do that, like, you run into the CAP theorem. And then you have to choose, like, basically, like, I don't know, I'm a little bit rusty on this, but like, I think that POSIX basically implies that you want something that is both consistent and partition tolerant and highly available, and therefore it has to be on the same machine. And actually, my opinion on this, for what it's worth, is that services that consume like a POSIX file system should communicate with each other via some other well-defined API. So be that like your maybe your sharded database is actually running across multiple containers across multiple hosts, but each shard has its own volume. So that's just my opinion. I'm happy to be challenged on that if anyone thinks it's silly. Any other questions? Sorry?
That's why NFS exists.
That's why NFS exists. And running NFS is always bound to give you a good time. I don't know, sure.
So is Flocker production ready?
Is Flocker production ready? No. Like just about everything else in this ecosystem. Sorry?
What is the plan? When would that be?
Okay, so we're tentatively planning to have something ready by DockerCon in June. Yeah, we're currently at 0.3.2. And really the first version of Flocker was just sort of a technology demo that says, look, using this you can move stateful containers around. But at the moment it only works on like one user, maybe on their laptop. They have an application manifest and a deployment manifest, and they write these files, and that describes the entire desired state of the cluster. And then they run Flocker deploy, and it goes and logs into all the hosts and inspects the current state, and then changes the current state to match the desired state, including moving volumes around if necessary. And that's fine for one user who's playing with it, but in production, you actually want like a multi-tenant API that can handle concurrency. And so that's what we're building now. And yeah, so watch this space.
This is a very general question, and maybe a naive one. But I get the feeling that a lot of the benefit Docker provides is especially valuable when you're dealing with systems that are handling very high scale.
Mm-hmm.
But I can also see how the encapsulation and boundaries that it defines just makes things more orderly, even for small systems, in terms of defining them. Maybe you get reuse, you can use someone
Yep.
else's container. And I was wondering about your impression, given the state of where things are at now, do you think that Flocker and Docker and tools like that actually would provide a productivity benefit to people who are working on systems that don't need to handle large scale, just as a kind of, I'm making a back end for a mobile app,
Sure.
or a web app, and I just want an organized way to do the architecture, and I want a nice workflow on my laptop. Are things at a state where that is a prudent choice now, or is that a bit of a waste of time? This is really only relevant for big boys who are handling a gajillion requests a second.
Sure. So I'll just summarize that for the recording. Basically, like, does it make sense to use Docker for only big scale, like only very large scale stuff, or for small projects and large projects. I personally think that people should use Docker, or at least containers, for everything. I think that it really is just a much nicer way of packaging up the dependencies of your app. And the nice thing is that that can then be deployed anywhere. So, yeah, short answer. I think, containers should be used on all scales. So, brilliant. So I'll wrap up at this point. There'll be some more Q&A after Adrian's talk. So feel free to pester me then or afterwards. So just quickly, actually just very quickly on Flocker, you can check it out on GitHub. There's a Vagrant tutorial that you can run through that's pretty easy to get started with, and you can see it working. You can also follow us on Twitter, and come and hang out with us on IRC if you're into that sort of thing, because we love chatting on IRC, and we've got lots of friendly people in our chat room. And just finally, we are hiring both in San Francisco and also in Bristol in England, and in Cambridge, Massachusetts, and all over the world. So yeah, if you want to come and work on this stuff, then give me a shout. Thank you.